we looked at the various hormones, all right? Yeah, you should know these hormones. These are really important. You just have to know what they are and what they do, how they affect you. And we looked at what hypothalamic release hormones and inhibitory hormones affect the pituitary. Now, when it comes to the neurohypophysis, there are no release hormones, there are no inhibitory hormones, because there is no glandular tissue. The posterior pituitary or neural hypophysis is just an extrusion of the hypothalamus. So there's no need to have anything to cause a release or an inhibition. What you make in a couple of hypothalamic nuclei is released into those venous capillaries. But with the anterior pituitary, which is glandular, you need to have a mechanism for stimulating those glandular cells to produce and or release hormone, or to inhibit that production and release. So with ACTH, corticotropin release hormone, vasopressin, antidiuretic hormone, but it's mostly cortical release hormone, corticotropin release hormone. There is no inhibition. You do not inhibit ACTH. Small amounts of ACTH are kind of necessary for life. Remember, your corticotropins, that your corticosteroids that you're releasing in the adrenal cortex, if you stop releasing those, you're going to have serious physiological problems. So there are always small amounts present and available, no inhibition. Thyroid stimulating hormone, thyrotropic hormone, and growth hormone inhibitory hormone, or somatostatin. And the reason we have two names for several of these is because initially vasopressin was described, later it was antidiuretic hormone. Initially, growth hormone inhibitory hormone was described, later, since it has multiple effects, somatostatin. Luteinizing hormone, release hormone. Well, yeah, but it also affects FSH, thus gonadotropin release hormone. So you should know the release hormones for these and the inhibitory hormones. Oh no. I'm missing right my slide. 7 disappeared. Pro-opiomelanocortin. This is a wild and crazy critical molecule. This molecule is necessary? That's beside the point. This big molecule is chopped up to make all of these little molecules. They have tremendous effects on melanin, on your immune system, on lipid metabolism, obesity, adrenal problems, pigments, skin and hair pigments. So they're really important. I'm not going to have you chop this up. No, that's silly. That's ridiculous. That's biochemistry. I do want you to understand pro-opiomelanocortin. It's an important molecule. You could say, oh, it's involved with, skin issues and all these things. Sorry, I have to close this, open up something, because it just, when I made this review, it didn't catch, so to speak. Questions at this point? All right. And then we transition to the limbic system. The interactions of the limbic. Once again, I'm not going to give you any chart like this, no. But this is really important to understand that the interactions involving the limbic system are really important. So, we looked at the development of the hippocampal formation. This is important because, once again, you have a structure in here that has two levels of folding, and that allows you to have some very, very important sets of synaptic interactions. This increases tremendously the amount of neuron-to-neuron interactions that can take place. We looked at the structure of the fornix. This is an important structure within the limbic system because it ties together the left and right limbic system, the anterior and the posterior. You know, it goes everywhere within the limbic system, from the mammillary bodies all the way up to the amygdala, etc. We touched briefly the other day on memory. I'm going to take you to another aspect of memory in just a second. But, you know, the inputs, you have temporary storage, short-term storage, long-term memory. Learning and memory are like this. They're just tied together so tightly, glued together. There's no separating them. And understanding how this works is really important. Please take time to carefully read the text associated with this. Declarative memory versus non-declarative, or explicit versus implicit. These are two components of memory that are really different, really interesting. Facts and events. Okay, I know you've all taken either human physiology or anatomy and physiology. And what you realize is, with anatomy, and you realize that in part of this class, there are a lot of very discrete things you have to learn. Okay? You learned a whole bunch of bones, you learned a whole bunch of muscles, you learned a whole bunch of brain parts. Those are discrete facts. Then, and by events are what you hated about school growing up, elementary school, where you learned, yes, 1492. Okay, 1492 to all of you should be a date drilled into your brain. You should know that in 1492, Christopher Columbus sailed to North America. Okay, fine. That's an event. However, there's a lot more that goes on with memory. I'm walking back and forth. Am I doing a lot of memory work right now? Well, the reality is I am. I learned how to walk a long time ago, and most of the time I do a pretty decent job of it. But I don't think about it. It's a skill that I have. It's a skill that all of you have. I notice on occasion you're looking at the board up here and you're writing notes. You're not thinking about the sequence of letters when you write. Maybe you do. But what you think about mostly are the words. And then automatically, as you write, you put those words down. And if your penmanship is decent, when you get home, you're able to read those words. And they do various things for you. I know some of us have terrible So implicit memory is essentially, in many respects, how you are using the stored facts and events. The facts. You've got the alphabet that you learned in kindergarten or whenever you learned it. Okay? Then maybe in second or third grade you learned cursive handwriting. I don't even know if they teach that anymore. But you learned how to do that. And so now you're sitting down there writing and taking notes. Priming. Priming is your ability, and I'm going to take you to some shortfall with some of these. Priming is your ability to determine how to start doing something. You know that there's a sequence of events for you to write your notes. You have to open your notebook, you have to open a pen or pencil, you've got to click to get the lead going or expose the nib of the pen to write, and then you have to write. There are all those things. Simple classical conditioning. You know this. This is the Pavlov's dog experiment, where the dog was conditioned to respond to something. If I tell you, well, an alarm goes off in the home, all right? It's going to bring a conditioned response into play. We're going to walk out of the room. I'm going to tell you to turn left, go down the stairwell here. Don't go over to the elevator because there's an alarm going and the elevators might be disabled. Or they might become disabled when you're in them, which is even worse. So, non-associative learning. Non-associative learning in many respects is when you're learning novel, new things that you have no way of associating with anything else. You do this frequently, okay? Where you learn something that is entirely new, but it's not a discrete fact. So when you learn a new structure in the brain, that doesn't go there. That goes over to facts. But now you're learning a new musical instrument to play. Oh, you have to use different fingers. You have to use all the same fingers differently. People assume you don't grow new fingers for each instrument you learn. So there's a lot going on here, okay? Skills and habits, once again. Habits, I'm walking. It's a habit. Skill, I'm talking to you. I'm lecturing on this. That may well be a skill. I don't know. So you should, and once again, there are a couple of paragraphs on declarative memory or explicit memory and non-declarative memory, implicit memory. Take a look at those. It really is kind of neat. I want to wrap up with one bizarre event. The story of HM. Anterograde and retrograde amnesia. Have any of you gone in for like major surgery where they put you out and cut you open? Okay. They gave you a drug that's an amazing drug, Versed. Why do they give you this drug? They tell you it's a pre-anesthesia. They give you two things with your pre-anesthesia. One is a drug that's going to kind of ease you into nirvana, okay? You are going to be one with the universe at that point. And they give you a Versed with it. And then they give you all sorts of really high-level octane to take you to Mars and back. And what Versed does for you is something really amazing. It prevents you from forming short-term memories. If you can't form short-term memories, what else can't you form? Long-term memories. Cool. Why do they give that to you? Because we're essentially individuals. Every one of us is different. We all metabolize these chemicals at a different rate. Our livers, our kidneys, our metabolism in general varies.